Hi guys, I am Chakwa and I am back with Maths XYZ, and in this lesson we will be dealing with analytical geometry on how to find an inclination angle of a straight line. An inclination angle is an angle measured from the horizontal with a direction of anti-clockwise from the horizontal to the line. So the equation of the inclination angle is tan theta is equals to m, of which our m is the gradient and our theta is the angle of an inclination. The angle of an inclination, the value of that is always between 0 and 180. The angle of an inclination is always between 0 and 180, and it's the angle which is measured, is an angle which is measured anti-clockwise from the x-axis into a straight line. Remember, it's always measured anti-clockwise from the x-axis into the straight line, and the value of that is always between 0 and 180. And an equation for that is equals to tan theta is equals to m, of which m is our gradient and our theta is the theta is the angle of the inclination. All right, let's do a quick example and see how to find an angle of inclination. To find an angle of inclination, for example, if we were to find the angle of an inclination of a straight line which is passing through point 1:1 and also point 4:7. So we have 2 point A and also point B, and we are told to find an angle of inclination from the x-axis to the straight line which is passing through those 2 points. So the first thing that we have to do is to find the gradient. For this question, we don't really have to find an equation for straight line, because we know that if we have the gradient, then we can find the value of the angle of inclination, because tan theta, tan of that angle, is equals to the gradient. So to find the gradient, we know, guys, we have to use an equation y2 minus y1 divided by x2 minus x1, and for this one, this is my first point and this one is my second point. Then we're going to have 7 minus 1 divided by 4 minus 1, which will give us it's equals to 2, because this will be 6, this will be 3, it's equals to 2. Then from here we have our angle of inclination, tan of the angle is equals to m, of which m is equals to 2. So to find the angle of inclination, theta is equals to tan -1:2. So from your occasional calculator, if you're using a calculator the same as mine here, what you do is to press shift from the calculator, guys, is to press shift from the calculator, and after pressing shift you go to tan. It's shift tan. You see that it looks like tan and having an exponent of -1 and also the bracket. So then you can put 2 there, and that will be equals to 63.42. So if you're using a casual calculator like mine, what you do is to press shift, tan, and then also the value of the gradient. So it will look like this. After pressing shift and tan, it will look like tan into an exponent of -1, and it will always have also have an open bracket, and then you put the value of the gradient and you close that, and it will give you the value of your theta. So that value will be equals to 63.43 degrees. That is the value of our inclination angle. Then from here, what we need to do again, another question that we need to do is to find an angle of an inclination. Sometimes it will help you to draw the straight line, to draw the graph, so that you can see on where it's being measured to and where it ends. It's always from the x-axis, the positive x-axis, anti-clockwise to the straight line, to the equation of to the graph, I mean to say. But then let's do this one, which is to find an angle of inclination of the graph which has an equation of y is equals to x minus 2. So this is the equation of the graph that we have to find an angle of inclination of. For this one, I will draw, guys, so that you guys can have an overview of how it looks like. So for this question, we have our y-intercept, which is equals to -2. You can say this is -2, which is our y-intercept. Then it will be 0 to -2, which is somewhere there. This is our 1, this is -2. Our 0 to -2 is somewhere there. This is the gradient for this equation. It's equals to 1. It's invisible 1 there. Then from here, what we have 0 is to -2, which is 10. This is the our y-intercept. And having our x-intercept for this one, it will be x-intercept means that our y is equals to 0. So it will be 0 and then it will be +2. Then that means that our value of the x-intercept will be 2 is to 0. Then our 1 there, and this will be our 2. So it's somewhere there. So this is the straight line that we have to deal with. All right. Okay, let me just draw it nicely there. Drawing it nicely, guys. There we go. This is the straight line that we have to find an angle of inclination for. So the angle of inclination, where will it be in this graph? It's always measured from the x-axis to the graph, to the line. So it will be always from the x-axis anti-clockwise to the graph. So this is the angle of inclination that we have to find. So to find the value of theta there, what we need to do is to say tan theta is equals to the gradient of the line, of which this is the gradient of this line, and the gradient of this line is m is equals to 1. Then we're gonna have our tan theta is equals to 1, and then theta, it will be tan -1 into 1, and to find that it will be shift into tan, and then we have 1 there, and that will give us theta it's equals to 45 degrees. So theta and this angle is equals to 45 degrees. All right, guys, you see, it's better sometimes to just draw and see how it will look like when you have drawn it, to show that it's from the x-axis up to the angle, up to the straight line, which is the straight line, which is the straight line, and the gradient of the straight line is m is equals to 1, and the value of theta, of which we have calculated it using tan theta is equals to the gradient. We found that is equals to 45 degrees. And then from here, let's do another question which is a bit different from this one, and I'll show you guys how to deal with questions like that if you get them in a test or when you are doing your classwork or homework. All right, when you are dealing with an angle of inclination, guys, always remember that it's measured from the x-axis anti-clockwise to the line, to the straight line. All right, for this one, if you have a gradient which is negative, a gradient which is a negative, and then to find the angle of an inclination for that, you will always get an whatever you find if you equate your tan theta is equals to the gradient, and your gradient, suppose it's a negative. Suppose your gradient is a negative. So what you do is to find the gradient, which is theta is equals to tan -1 of the gradient, which is a negative gradient, right? And then from here, what you do after finding the value of theta using that, you have to add this value of theta with 180. Whatever you find, if you have the gradient which is negative, is tan -1 of the negative gradient, and after finding the value of that, you have to add 180 to that. Reason being is to find, because if it's a negative gradient, that means that your angle of inclination that you're gonna find, it will be clockwise. So to make it anti-clockwise, you have to add you have to add 180 so that it will be measured from the x-axis going anti-clockwise. All right, let me show you an example on what I mean by that, guys. All right, with the very same question that we did, which is y is equals to, for the first one it was x plus 2. For this one, let's make it negative x plus 2. All right, and then we're gonna have this. All right, and then our x-intercept for this one, it will be 0 is to 2. Our x-intercept will be 0 is to 2, okay? 0 is to 2, which is 1. This will be 2, so it will be 0 is to 2. And your y-intercept for this, and our x-intercept for this case, it will be, this one will be 0, so that it will also be 0 is to 2 again. It will be 2 is to 0 as well. So this, it will be somewhere there. So what we have here, we have a straight line which is passing through here and there. So this is our straight line, guys. Okay, and then from this one, our angle of inclination, as we know, is always from the positive x-axis going to the to the going to the line. So this should be our angle of inclination, which is theta. All right. And then let's see, when we are using the equation to find an angle of inclination, if it will get us to that. So from here we have tan theta is equals to m, and our theta here, it will be tan -1 of m, of which our m is equals to -1. And then from here, what we're going to have is to find tan of -1, which will give us -45. All right. -45 cannot be this angle here, because this is measured positive from the x-axis, so it has to be positive. So if it's a -45, that means it's not that angle. So what we need to do, that angle is actually -45, it's actually measured clockwise from the x-axis. This is -45 degrees. Then to find the positive one, what we have to do is to add 180 to this one, so that we can get, it will be -45 plus 180, which will give 135 degrees. So the angle of inclination, correct angle of inclination, is actually equals to positive 135 degrees. So to find that, always if you are given a negative gradient, after finding the angle of inclination using that gradient, please add 180 degrees, so that you can get the one which is measured anti-clockwise from the positive axis. Because if you just leave it at that, you will actually have measured this one, which is clockwise. It does no longer fit the definition of an angle of an inclination, because angle of inclination is measured from anti-clockwise from the x-axis. So if it's measured clockwise, it's no longer an angle of inclination. Alright guys, I hope you understood this lesson as well. Please, if you didn't, or if you have any question, please just drop us a comment and we'll have a follow-up on it. Please don't forget to subscribe to Maths XYZ so that you can get daily notification when we upload videos. Thank you.